Hello everyone, welcome to iQuanta. My name is Nitin. I'm sure all of you are doing great. Guys, this is the fourth video of percentages. In this video, we're going to cover one of the most important concept of this topic called percentage change. So what is percentage change? Let me tell you from the beginning, right? So guys, what is percentage change? I'm sure you all remember the formula which we were, taught in school. The formula was that, change upon initial value into 100, all right? What change is all about? The change could be increment, it could be decrement as well. That's why we used to call in school that it is percentage increment or percentage decrement. Both it could be there, right? Okay, now what next? Guys, if you remember what we discussed in the last session, we discussed a very good, formula that let's say if someone is saying that A is what percentage of B, right? So here, we used to say what? We used to say this is A upon B into 100, right? Now, if we compare this formula with this percentage change formula, right? So here in the right side, it is written that A upon B into 100, and that is written change upon initial value into 100, right? So if we compare this with this one, so we can say change is nothing but a small a, and initial value is nothing but a small b, right? This is how we can compare. So change means small a, initial value means small b, so we can write this as well, that a is what percentage of b, where a is change and b is initial value. So this is how we can compare the things, and we can say this formula can be written as that change is what percentage of initial value. So this is how we can say percentage change as well, that change is what percentage of initial value, right? And guys, this is how we can also say that percentage change is always calculated with respect to the initial value, because initial value is in the denominator. So yes, it is always calculated with respect to the initial value, never calculated with respect to the final value. This is very important point which you have to remember in terms of solving the applications. All right, now let's do some basic examples to understand this more. Suppose guys, we are given that there is a value, let's say 80, right? And it has been increased by 20%, all right? So 80 here is the initial value, simple, and 20 here is the percentage, 20% is the percentage increase, and we need to find the final value, right? So we can do this in a lot of ways, but let's try to do this with a very easy kind of method. So what we can say that the value of the change will be what? It will be nothing but or you can say value of the increment will be what? It will be nothing but 20% of the initial value, and initial value in this application is 80, so we can say it is 20% of 80. Now 20% of 80 must be what? 10% of 80 we know is 8, so 20% of 80 must be 16. This is what we have learned in the previous classes as well. So 80 must increase by 16, that means it must become 96. Very basic thing, right? Okay, let's try to do one more example on the basis of that. Suppose we this time we decrease the value, and let's see what do we get. Now guys, let's say we have a value 140, and let's say it has been decreased by 25%, and we need to find the initial value, right? So the decrement should be how much? We can again say this has to be percentage of the initial value, and initial value here is 140, obviously. So 25% of 140 should be the amount of the decrement. Now 25% is nothing but 1/4, right? This is what we have discussed in the previous sessions. So 1/4 of 140 is how much? It has to be 35. So the value is decreases by 35, that means 140 must be decreasing by 35, and it should be 105. So we can say 105 has to be the final value, right? Okay, so these are the two examples when initial value is given and percentage change is given, and we need to find the final value, right? Okay, now let's do another example in which we are given the initial value and final value, and now we have to find the percentage change. All right, let's say guys, we are given a value 120, and it has been increased to 156, right? Now we need to find the percentage change in this example. Very simple example, right? I'm just telling you to understand the basics of this concept, right? Okay, so what I told you in the previous slide, that percentage change is nothing, this formula, and we converted this formula into this. That means we can say percentage change is, that change is what percentage of initial value, right? So guys, here we'll be doing the same thing, right? So one thing is sure, that this is being an increment, right? 120 is initial value and 56 is final value. Final value is more than initial value, that means it is definitely an increment, right? And what we learned in the previous slide, that percentage change, or you can call percentage increase in this particular example, right? We can say percentage increase is what? That increment is what percentage of the initial value. All right. Okay, now let's see what is the increment and what is the initial value, right guys? So increment here is how much? You can simply see that increment is 120 plus 36 will be 156, right? So the value of the increment is obviously 36 and initial value is obviously 120, right? So we can just put it here that 36 is what percentage of 120, all right? Okay, now what we can say, we just need to find that 36 is what percentage of 120. So we can say here that 36 upon 120, let's try to simplify this a bit. So they both are divisible by 12, right? So this will be 12 threes are and this will be 12 tens are, all right? Now this is 3 by 10. Now guys, we all know that 1 by 10 is nothing but 10% is. So 3 into 1 by 10 has to be 30%. That means the percentage increase in this case is nothing but 30%. So this is how we can make the things easier. Right now I have written a lot, so that may be the reason you might not be finding it easy, but trust me, once you get perfect, you avoid writing that much. This method can be very nice in terms of solving the difficult calculations. We can actually do one more simplification in this method. What is that? Let's say we have the similar question, right? 120 to 156. In this method, guys, I will also not write so much so that you can understand the importance of this method as well. Now, what else we can do here? There is one thing, if you observe that, in the end we are cancelling everything, right? So if you are cancelling everything, then why don't we cancel from the beginning, right? For example, if you see 120 and 156. So guys, in these two terms, if you observe that 12 is the highest common factor, right? So if we cancel both of them by 12, so this is 12 tens are, we know that, and this one is 12 into 13, so this will be remain at 13 only, right? What we did, we just simplified both of these terms by 12, so it will be 10 here and it will be 13 over here, right? Now look at this, the increment here is 3, all right, and what will be the percentage increase now? The percentage increase, I just told you here that this is nothing but that increment is what percentage of initial value. Now increment is 3 and initial value is 10, right? So increment is 3, let's write here, initial value is 10, so it is again 3 by 10, and 3 by 10 we just know that it's 3 into 1 by 10, 1 by 10 is 10%, and we can say 3 into 10% is 30%. So this is how also we can do the same question and we can do this faster, right? See, these numbers are very easy, so maybe this method is not looking as effective, but once you apply this method in the difficult numbers, if you cancel the numbers and write the simplest numbers, trust me, this method will work like the magic. All right. Now let's understand another concept of multiplication factor in the percentage change. Very important concept. Let's understand this first, and then I'll tell you the application of this as well. All right. Let's say, guys, we are given that a particular value, let's call it initial value, right, and it has been increased by 20% to get a final value. Okay, so basically let me tell you that multiplication factor is a factor which should be multiplied, as it is called the multiplication factor, and basically it is something which creates a relation between the initial and final values when the percentage change is given. So that's why I took an example in which percentage change is given and we do not know the values of initial and final value. In fact, we will be finding a relation between initial and final values with the help of the percentage given to us, percentage change given to us. All right, how we can do that? Okay, I want to build this relation from the beginning, right? So the basics is what, guys? The basics is that whenever there is an increment, so the increment is always added to the initial value, right, to get the final value. Very simple thing, right? Now, the increment in this case, we just know that it's 20%, and we just learned in the previous slides that the percentage increase is always calculated with respect to the initial value, right? So 20% of what? 20% of the initial value. That means the amount of the increment is 20% of the initial value. We can just say that. All right, and the right hand side is the final value. We know this thing. Now we can write 20% in a lot of ways. We can write 20% in a fraction. We can convert this into the decimal as well. Let's write all the ways. So one, we can say initial value plus the fraction of 20%, which is 1 by 5, right? And on the other hand, we can also say that that 20% is 0.2, right? In the decimal, we can say 20% is 0.2, all right? Now this also is a final value. Now in this method, if we just take initial value as common, right, we'll have what? We'll have 1 plus 1 by 5, right? Simple. Just a second. Alright, so in the first method we can say what? This is initial value in the bracket 1 plus 1 by 5, and the right hand side is the final value, right guys? In the second one, again if we take initial value as common, so in the bracket it must be 1 plus 0.2 here, alright? So 1 plus 0.2 has to be the final value, simple as that. Now 1 plus 1 by 5 is how much? We all know 1 plus 1 by 5 is nothing but 6 by 5, right? Okay, and in the second way we can say what? That this is initial value into 1 plus 1 by 1 plus 0.2 gives us 1.2, right? Okay, so these are, we can say what, are the relation between initial value and final values, right guys? Alright, and I tell you what, in multiplication factor is something which is being multiplied, right? So you can say that initial value is being multiplied by 6 by 5 and by 1.2 to get the final value. So this 6 by 5 and 1.2 are actually called the multiplication factor. Let me write this here, that 6 by 5, and this 1.2, they are the multiplication factor. Alright. Okay, now what is the concept behind? It's very simple. Multiplication factor is something which is multiplied to the initial value to get the final value. We can write this here, initial value into the multiplication factor will give us the final value. Alright, now how do we get the multiplication factor? That's the most important question over here, that how do we find the multiplication factor quickly? So guys, let me tell you that you're not supposed to do that much. If you're doing that much work, then any other method will be better than this, right? So we are not supposed to do that much. We are just going to write this, and the main question is how do we find the multiplication factor, right? So here in the case of increment, we can say what? That multiplication factor is nothing but 1 plus, alright, the fraction or the decimal conversion of the percentage increase, alright. The percentage increase is which percentage increase? The one which is, will be given to us. Simple as that. 1 plus the fraction or decimal conversion of the percentage increase. For example, in this case guys, the percentage increase is 20%, right? And we all know 20% in fraction is 1 upon 5. So 1 plus 1 upon 5, the fraction conversion is 1 by 5. 1 plus 1 by 5 is 6 by 5, and that is why it's written 6 by 5 over here, right? If you write in the decimal, so decimal of 20% is 0.2, the 1 plus 0.2 is 1.2, so this is how we are writing it, simple. And one more thing guys, we can definitely find multiplication factor in this way, but how do we solve, which multiplication factor should we use? The fraction one or the decimal one? So let me tell you, in terms of calculation, the fraction one is, far better. Why? In decimal one, there can be sometimes, calculation problem. Maybe the final value or initial value are not comfortable enough, that are getting cancelled with the help of the decimal number. But with the help of the fractions, most of the time, they get cancelled out. I'll definitely give you some examples as well, right? Okay, let's first, find a few more multiplication factor. Let's say guys, there is an increase of 10%, right? So now what should be the multiplication factor, right? So we can say what? 10% in fraction is 1 upon 10. So 1 plus 1 upon 10 has to be 11 by 10 over here, right? And in decimal, 10% in decimal is 0.1. So 1 plus 0.1 has to be 1.1, simple. Okay, that was just still, an easy number. Let's say it is 25%, right? So if this is 25%, in fraction, 25% is 1 upon 4. So 1 plus 1 upon 4 has to be 5 upon 4, right? And in decimal, 25% is 0.25. So 1 plus 0.25 has to be 1.25, right? Okay, these are still easy. Now let's take 16.66, all right? So guys, 16.66% is in fraction. We all know is 1 upon 6. So 1 plus 1 upon 6 has to be 7 upon 6, which is still, a better fraction. But if you do it in decimal, so 16.66 will be 0.1666, and 1 plus 0.1666 will be what? It will be 1.16666, right? So this is something, not very much friendly in terms of the calculation. That is why I was telling you that we shouldn't write multiplication factor in the decimals, rather than we should use it in fraction, because they are very much friendly in terms of the calculation. Alright, so this is all about the multiplication factor when there is percentage increase. Just remember guys, we are not supposed to write so much. We are just supposed to write this initial value into multiplication factor as a final value. And how do we find the multiplication factor? With the help of the percentage change and by using this basic concept. In the beginning you have to look at these for a few times, but trust me, after solving a few good number of questions, you do not have to look over there. It will get into your mind. All right, now let's do a very basic example on the basis of this, right? Okay guys, let's say we have an example, right, in which one value is given. Value is not known, right? Let's just call it initial value, and it has been increased by 25%, right? And the final value is coming 225, and we need to find the initial value, right? How do we do that? Just using the multiplication factor. So when there is the increase of 25%, right, let's use it in fraction. As I said before, fraction is comfortable in calculation, right? So 25% in fraction is 1 by 4. Multiplication factor will be 1 plus 1 by 4, which means 5 by 4, all right? So let's write what? Let's write initial value into the multiplication factor, which we just calculated is coming 5 upon 4, has to be the final value, and we know the final value, which is 225, all right? Let's find the initial value. So initial value into 5 by 4 is 225, doing the cross multiplication, so initial value has to be 225 into 4 upon 5, right? Now 225 upon 5 is how much? Let's do that. It's 45, and 45 4 is 180. So initial value has to be 180. You can also do the cross checking. 180 when increases by 25%, 25% of 180 is actually 45. 45 when added to 180, we are getting 225. So yes, this is how we can say that initial value is 180. So guys, this can be one of the best ways of finding the initial value with the help of the multiplication factor. We can use multiplication factor in the other application as well. For example, we can use multiplication factor to find the final value when initial value and percentage change is given. We can also use this to find the percentage change when initial and final both the values are given. But the best application of multiplication factor is to find the initial value, right, whenever the final value and the percentage change is given, right? And in these kind of question, this method can be extremely helpful, right? So I would suggest you to use multiplication factor, especially when the initial value is being asked. All right, let's do one thing. We discussed all of this with respect to the percentage increase, right? Let's understand again, let's understand this in the case of percentage decrease, right? Okay, so let's say the same data, right, but let's make just one change. Instead of percentage increase, right, let's make it decrease. So it will actually be very much convenient. We just have to change a few signs, that's it. Okay, let me do this fast then. This time it must be initial value minus the decrease, right guys? Simple. It has to be initial value minus the decrease, because this time I have taken the example of the percentage decrease. All right, now what next? This is decrease, so this should be minus, right? This should be also minus, this should be minus. All right, let me clean all the required changes, right? All right, that's done. Fine, coming back to this. So this is minus of 20% because it's decrement, obviously. Converting 20% either into the fraction or into the decimal, the same conversion, right? 1 minus 1 by 5 will give us 4 by 5, and 1 minus 0.2 will give us 0.8, right? So we can say the multiplication factor is either 4 by 5 or 0.8 in case of 20% is decrease, right? Now obviously we are not supposed to write so much again. We just have to write this equation, or you can say relation, right? And how do we find the multiplication factor this time? Last time we were adding the conversion into 1, right? This time we'll be subtracting that conversion again from 1. So we'll say 1 minus fraction or decimal conversion of the percentage decrement. All right, simple. For example, here guys, 20% is 1 upon 5. So 1 minus 1 by 5 is 4 by 5, and 1 minus 0.2 is 0.8. This is in fact visible as well. I have written the same thing in the bracket. so that you can, also see what is happening here, right? Okay, now let's take another examples. Suppose 10% is being decreased, right? So 10% in fraction is 1 by 10. 1 minus 1 by 10 is 9 by 10, simple, right? And in decimal, 1 minus, it will be 0.1. 1 minus 0.1 will be 0.9, very simple. Okay, suppose if I take another example, let's say 33.33% is, right? Let's decrease this by 33.33%. So 33.33% in fraction is 1 by 3. 1 minus 1 by 3 has to be 2 by 3. It will be written here in fraction. In decimal, it is what? It is basically 0.333, right? Now 1 minus 0.333 will give us what? Will give us 0.6666 something, right? So we'll be writing 0.666 as a multiplication factor in decimal, which is again not very much comfortable in terms of the calculation. That's why I told you, to write the multiplication factor always in the fraction, because that is extremely helpful in terms of the calculation. Just a second. Alright, so this is about the multiplication factor when we are, doing the decrement, right? Okay, now let's do an example for that as well. Suppose, guys, there is a value which we do not know again, right? And it has been decreased by 14.28 percentage to get the value as 90, all right? And now again we have to find the initial value. How do we do that? All right, just like the previous case, it decreases by 14.28 percentage, which is 1 by 7 in fraction. In decimal will be very difficult, so let's not use it. Let's use only in the terms of fractions. So 14.28 is 1 by 8. Decrement, so 1 minus, 14.28 is 1 by 7. Decrement, so 1 minus 1 by 7 will give us 6 by 7, right? So initial value into 6 by 7 is the final value, which we know as 90, right? Simple. So initial value should be how much? It should be 90 into 7 by 6, right? Okay, 90 by 6 is 15, and 15 sevens is 105. So this is how we can say initial value is 105. Very simple way, right? If you want, you can cross check as well. 105 decreases by 14.28 percentage should get 90. You can cross check if you want to. All right, so you can see that again this question becomes so easy because we use multiplication factor, that is true in the fraction, right? So again, guys, whenever, as I said, we have to find the initial value, always use multiplication factor because it will ease the calculation a lot. All right. So this is all about the basics. We learned how do we calculate the final value, how do we calculate the percentage change, and how do we find the initial value when the other values are given. All right, now we'll be doing some very good application on this, right? So guys, question number 1 in front of us is what? It says that if the salary of A is 16.66% is more than the salary of B, and the salary of A is rupees 1400, then find the salary of B, right? Okay, so you can do one more thing. You can also, pause the video, try doing yourself for 1 or 2 minutes, and then again you can go back to the video, to see the solution. All right, let's see how we can do that. So they are saying that the salary of A is 16.66% more than the salary of B, and the salary of A is 1400 rupees, then find the salary of B. All right, guys, definitely the case of percentage change, right? Now, what happens that usually, as I told you in the beginning, that percentage change is always calculated with respect to the initial value. A lot of students know this, but still, they get confused with the language. Sometimes, the students are not able to understand that which is the initial value and which is the final value in the language of the question. So let me tell you one very basic thing. See, guys, maybe you're getting confused that the salary of A is the initial value or the salary of B is the initial value, right? So you can, understand this with just one hint, that just look at that the word, then or of is written before which term, right? So you can see that then is written here and then is written before the salary of B. That means the salary of B should be the initial value and the salary of A must be the final value. Simple. All right, so we can say what? Salary of B is the initial value and salary of A is the final value, right? And salary of A is given 16.66% is more than the salary of B, right? So 16.66% more than, simple. Salary of A is the final value, this is the initial value. Now, Good thing is that we also know the salary of A, right? We just know that. And we need to find the salary of B, which here is nothing but the initial value. So I just told you in the previous slide that whenever we have to find the initial value, the best way to do this can be the multiplication factor. So guys, what should be the multiplication factor when there is increase of 16.66% is 16.66% in fraction is 1 upon 6. Multiplication factor is 1 plus 1 by 6 because this is increment. 1 plus 1 by 6 is 7 by 6, has to be the salary of A. Salary of A is given to us 1400. Let's just put it. So salary of B should be 1400 into 6 by 7, right? Now 1400 into 6 by 7, 1400 by 7 is 200. 200 into 6 has to be 1200. That's it. So this is how we can find the salary of B in this question. Alright, let's move to the question number 2. Again guys, you can pause the video, try to solve it for 1 or 2 minutes and then come back to see the solution. The question says the salary of Kishan is 33.33% is less than the salary of Maya. Then find the salary of Maya is how much percent is more than the salary of Kishan. Alright guys, I just showed you in the last question that whenever the then or of is written, before which term, that term becomes the initial value. So then is coming, in this question then is coming before the salary of Maya in the first statement. So in first statement, the salary of Maya is the initial value, right? So let's write it salary of Maya here and salary of Kishan here, right? And salary of Kishan is 33.33% is less than the salary of Maya, alright? Question is asking that find the salary of Maya is how much percent is more than the salary of Kishan. So we have to do the reverse thing now. Maya is how much more than the salary of Kishan. So now then is written before Kishan. So in this case the salary of Kishan should be the initial value and salary of Maya has to be the final value, right? Okay. Salary of Maya this time is final value, Kishan is the initial value, and we have to find this percentage change in this particular change. Alright. How do we do that, guys? In this question you see that we are given no value, right? We used to use a multiplication factor when the initial value was being asked. But in this question a percentage change is being asked, right? We can use multiplication factor, I'm not saying anything like this, but multiplication factor might not be the best way of doing this question, right? So in these kind of question when no value is given, right, only the percentage term is given and percentage is being asked as well. So the best way of doing is the assumption, right? And what assumption? See guys, when the question is of percentage, the best assumption can be a value which is 100 or a multiple of 100, right? So here you see that it's 33.3% is less. 33.33% we know is 1 upon 3, right? So we should take salary of Maya which should be a multiple of 3, right? So that the calculation gets easy. So you can either take it just 3 or take it 300 because I also said that in percentages multiplication, multiple of 100 should be the assumption, that always makes the calculation easy. So let's take a multiple of 3 as well as a multiple of 100. Why multiple of 3? Because 33.33% is 1 by 3. If this will be the multiple of 3, 1 by 3 of the multiple of 3 will be easy, right? And why the multiple of 100? Because we are still solving percentages. So let's take this number as multiple of 3, also the multiple of 100. The best assumption can be 300, right? So let's take salary of Maya as 300, all right? This is being decreased by 33.33% to get the salary of Kishan, all right? So what is 33.33% of 300? 33.33% is 1 upon 3. 1 upon 3 of 300 is 100, right? So decreases by 100, that means the salary of Kishan should be how much? 300 decreases by 100 should be 200. So guys, with this assumption, when the salary of Maya is 300, the salary of Kishan is coming 200. Now let's put these values over here. Salary of Kishan now is 200 and the salary of Maya is 300. So let's see what should be the percentage change, right? Okay, very simple. The change, you see that it's an increment and the increment is how much? Increment is rupees 100, right? Now how do we find the percentage increase? I have told you before in the form of an example. Percentage increase is that the increment is what percentage of initial value, right? Increment is 100, initial value is 200. So we just have to find out that 100 is what percentage of 200, that we can say is 1 upon 2, and 1 upon 2 we all know is 50%. So this is how we can solve this, basic problem on percentage change. All right, guys, let's increase the level of the questions. Coming to question number 3. Again, you can, take a pause and try to solve it for a few minutes and then come back towards the solution. All right, question number 3 says the price of an item in 2023 is 8.3%, is 8.33% is less than its price in 2022. Its price in 2022 is 28.56% is more than its price in 2021. Now find the price of the item in 2021 if the price in 2023 is given rupees 660. All right, this time 2 percentage changes are happening, right? Okay, let's see what is given. Let's try to write it in terms of the initial value and final value terminologies, right? Okay, so first change is what? Price of an item in 2023 is 8.33% is less than the price in 2022. All right, so in this change, 2022 price is the initial value, right? Let me write like this: price in 2022 is the initial value, and price of 2023 is the final value, and price of 2023 is 8.33% is less than the price in 2022. All right, then they are saying the price in 2022 is 28.56% is more than its price in 2021. Now, then is given before 2021, so price in 2021 has to be the initial value, right? And the price in 2022 has to be the final value, right? So price in 2022 is 28.56% is more, all right? Let's write this here. Now, coming to the final question, they are saying that find the price in 2021. So this is what we have to find out. When the price in 2023 is given 660. 2023 price is given to us. All right, not a difficult problem now. This price is given, so with the help of this relation, we can find the price in 2022. And putting the price of 2022 here, we can find the price in 2021 as well. Simple. So this time, guys, we know the values, right? It's not like the previous question in which there was no value given. In fact, we know value of price of 2023, and price of 2023 in this percentage change is the final value, right? And we have to find the initial value here. And I told you a few minutes back that whenever we have to find the initial value, the best method is the multiplication factor. All right, so let's try to do this, especially this one, with the help of the multiplication factor, and then when in some time we'll look at this as well. All right, so multiplication factor should be how much? Initial value into the multiplication factor is the final value, but what should be the multiplication factor? There is a decrease, 8.33%. In the previous session, I told you how do we convert 8.33% is in the fraction. This is half of 16.66. 16.66 is 1 upon 6, so it should be 1 upon 12, right? Now, this is a decrement, so 1 minus 1 by 12 has to be 11 by 12, right, guys? So price in 2022 into 11 by 12 should be price in 2023, and that price we know, right? We know the price 660. That's good. Now the price of item in 2022 has to be rupees 660 into the cross multiplication into 12 by 11. All right, rupees 660 into 12 by 11, right? Now 660 by 11 has to be 60, all right, and 60 into 12 has to be 720. Simple application, right? So guys, we got the value of price of the item in 2022, means we got the value of this in this change, right? And in this change, price of 2022 is the final value. So again, we know the final value, and we have to find the initial value, which is actually the final question as well, right? Okay, so again, final value is given, initial value is to be found. That means the multiplication factor should be the best way of doing this, right? What should be the multiplication factor, right? So guys, this time 58.56% is increase. 28.56% is twice of 14.28. We know that, right? 14.28 is 1 by 7, so this has to be 2 by 7. Increment means 1 plus 2 by 7, that means 9 by 7 has to be the price in 2022. Price in 2022 is 720, that's it, right? So what should be the price in 21? It should be 720 into 7 by 9, all right. So 720 upon 9 has to be 80, and 80 into 7 has to be 560, that's it, right? So this was the final question to find the price in 2021, which came as 560 has to be the final answer. So this is how we can solve this wonderful question, right? Okay, so that was question number 3. Now let's move to the question number 4. A very nice question, right? You can take a pause and then solve, and then what's the solution? All right, question number 4 says that number of students in school A is 25% less than the number of students in school B. All right, again a percentage change. Number of students in school C is 8.33% is more than the number of students in school B. Find the number of students in school C is how much percent less or more than the number of students in school A. All right. Okay, so 2 changes are given and 1 change is being asked. Guys, in the last problem, if you remember, we knew one price, but in this question we are not given any absolute value. All the data is given in the percentage change, right? Interesting. Okay, first thing, students in school A is 25% is less than students in school B. All right. Then is written before the students in school B, right? So in the first change, number of students in school B is the initial value and school A is the final value, right? Okay, how much percent is more? In fact, less, 25% is less. All right, fine. Let's look at the second change now, right? The second change is that in a school C is 8.33% is more than the students in a school B. So in this change, number of students in a school B is the initial value and the number of students in a school C is the final value, right? And it is given 8.33% more, all right? 8.33% is more, that's it. Fine. Now look at the question. Question is saying that find the number of students in a school C is how much percent is less than the number of students in a school A. So the final question is about a relation between the students in a school A and school C. All right. In fact, we can write this here. School A is, in the final question, the school A is the initial value because then is written before school A, right? So number of students in school A is the initial value and the number of students in school C is the final value, all right? So in school C is how much percentage more or less than the number of students in school A. Okay, so that is the final question. So main point is that the final question is about the students in school A and school C, right? And school A is dependent on school B, school C is also dependent on school B, right? So that's the main thing, right, guys? So school B students will be, taken as a bridge to solve this question, right? Because it is given in both, is a common number, so should be taken, should be used to find a relation between A and C. All right, how can we do that? All right, no number is given, right? So we should solve this question with the assumption, right? How do we do the assumption? Guys, let's do one thing. Let's first write the multiplication factor as well. 25% is 1 by 4. There's a decrease, so 1 minus 1 by 4 has to be 3 by 4, right? Is the school, students in school A. This one, 8.33 increase. By the way, what is 8.33 in fraction? In the last question we used the same. It was 1 by 12, right? So increasing 1 plus 1 by 12 is 13 by 12. All right. The final one is the students in school C. All right. So you see that in both of them we have written students in school B, right? Now what should we assume, right? By the way, we can solve this question completely by multiplication factor as well, but that might not be very good method, that's why I'm using the assumption, right? How do we assume? See here we should assume students B as a multiple of 4 so that 4 get cancelled out and we are left with only the natural numbers to solve the questions quickly. Similarly here we should assume the students B as a multiple of 12 so that 12 get cancelled out and we get the easy numbers, right? We get the easy natural numbers to calculate in the end. So from this we are saying it should be the multiple of 4. From this we are saying that it should be the multiple of 12. So multiple of 4 and multiple of 12 is nothing but the multiple of 12, right? Because the LCM of 4 and 12 is just 12. So let's assume the number of students in B as a multiple of 12. We can take 1200, right? Because percent is multiple of 100. If you're not much comfortable, take it 120. Even you can take 12 also, right? But let's take 120. 10 should be there at least, right? So let us assume the number of students in school B should be 120, all right? So from first relation, we can say the number of students in school A should be, 120 into 3 by 4. That should be how much? We'll say 30 into 3 as 90, all right? In the second school, school C, it should be 120 into 13 by 12, right? So 120 upon 12 is 10, and 10 into 13 should be 130. All right, so we got the number of students in both the schools. In school A is 90, in school C is 130. Let's put it here, the final question. So number of students in school A came to be 90, in school C came up to be 130. All right, we are just using this one, that's it, right? The final question. So students in A is 90, school C is 30. So we just need to find out that 130 is how much percent is more than 90, because 130 representing students in school C and 90 representing the students in school A. Simple. So this is 40 more. Simple. What should be the percentage increase? Percentage increase is always, increment is what percentage of initial value. Increment is 40, initial value is 90. So we just need to find that 40 is what percentage of 90. 40 upon 90, we can say 4 by 9, right? And further we can say 4 into 1 by 9. 1 by 9, we all know is 11.11 percentage. So 4 into 11.11 is 44.44 percentage. So the final answer has to be 44.44 percentage is the number of students in school C is, 44.44% is more than the number of students in school A. All right. So this is how we solve this wonderful question as well. And that was the last question of this video, right? I hope you guys, enjoyed this video, because yeah, I have given, one of the best, possible questions in the end to make you understand the concept of percentage change. In the next video, I will come up, with some more concept of percentages, and then very soon we are going to start profit and loss as well. I hope you guys enjoyed the video, right? You can write your feedback in the comment. If you want, me to cover anything else, you can also write down in the comment. Thank you so much. Till then, keep studying and keep enjoying our videos. Thank you. Bye-bye.